Good morning, grades. So today's lesson, we're going to talk about misleading data. So this presentation is more related to just how you can have different presentations that might be misleading. So I'm just going to kind of go through some examples and talk about why they might be misleading, just to kind of give you guys a better understanding of how data can be misled. So here we have data showing more significant change. So one thing that you'll notice is that for this double bar graph, the graph on the right, so graph A, isn't actually starting at 0. So when you're starting and your data range, I guess, is a lot smaller. You see they both go up to, they both go up to roughly 400 in both graphs. However, when you're starting at 230, you're seeing a steady incline from year to year for the average house price in this example. Whereas you look at the graph on the right, the increase does not seem as significant when you're comparing the two cities of Fraser Valley and Victoria. But it's either way, you can see that the prices in Victoria are going up more than they are in Fraser Valley. However, the actual change looks significantly more substantial in the graph on the left. So when you have a difference of scale, so when I've talked about this in the last lesson, in the first one on the far left, you see that there's no scale at all, and it makes you think that Vancouver gets like 30 times more rainfall than Whitehorse, when in reality that's not the case. Even in the middle one, you're still getting that same perception because they're not starting at 0. So they're not having like a base of absolutely 0 rainfall. But in the one on the far right, you're able to see that, yeah, Whitehorse actually does get rainfall. If people were to look at this graph and decide, oh, I want to go somewhere where it doesn't rain, they're going to just pick, okay, well, there's obviously no rain in Whitehorse based on the first graph, and the second graph, they might see a little bit. But then in the last graph is the best representation, being that it does start at 0 and it works its way all the way up to about 1,000 millimeters of precipitation annually. So looking at the three of these in comparison, obviously the best case scenario where you're getting the most information would be your graph on the far right. Here we just have some misleading graphs. So these are kind of separate from each other. So on the left one, where we have grade 8 students who scored higher than 80% on a math test, and that's just talking about the total number of students. The fact that you have the boys graph as wider than the girls almost make it seem as though there were more boys, when in reality there was 20 girls and probably about 19 boys that received kind of a higher grade according to this graph. So that's one thing that might be deceiving, is you look at it and immediately you think, all right, there's more to the actual bar, so that means it must be more significant. Same thing with the ice cream flavors. When we look at bubblegum, it just has a huge ice cream cone, but the bigger the cone doesn't mean more students. So when we're looking at this, we see that chocolate actually is the most popular, but it isn't the one that's sticking out the furthest. And when you compare vanilla to bubblegum, 2 of those vanilla ones is equal to the size of, or the length of, one bubblegum. So you're getting a very, very deceiving graph here, letting you know that just because the size of something is bigger doesn't mean that it's any more significant. And the last one, the one on the left, it's a good representation. However, the scaling on the left side does not need to go that high. You could have your range between 0 and 20, and you'd get a better representation of the number of students that like that music. You don't have to go all the way up to 50. It just makes it seem, so much more unpopular. And maybe you're thinking, okay, well, what type of music is the most popular? If they have a range of that, or a scale that goes all the way up to 50, there must be something else that's missing that could go up that high, or they don't have enough information, or they haven't asked enough students. When you're looking at the one on the right, there's no percentages that are telling us any information. It's talking about just favorite drinks at lunch. So it's harder to actually figure out, okay, well, which one is the most popular, water or milk? And the fact that they also have the little bit of milk moving away makes it seem like that is a significant drink, when in reality, if you take a protractor and you're measuring, water would be the bigger section. So these are all kind of misleading graphs and information for particular reasons. So what you're going to have to do is you're going to have to go and kind of be a critic of graphs and look at ways that they might be misleading. Look at ways where their information might not be 100% accurate. What they might be doing wrong to make it seem that way. And sometimes if you're making information in a graph, you might want to change these things and set them up in a way that make you look or your information look more significant. So in the meantime, you're going to do the Math Makes Sense 7.2. You're also going to complete the Google form. If you have any questions, make sure that you bring them to the Zoom lessons that we will have. And have a great day.